Fourier series, session 4, even and odd functions. Now let us know how the even and odd functions can be determined. For example, if I consider a function f of x, Now let us check this function f of x as even or odd. The f of x function is said to be even if I take f of minus x, then I need to get f of x. If I consider f of minus x, the answer is f of x, then that function is called as even function. And if I want to find out whether the function is odd, if I consider f of minus x, then if I am going to get minus of f of x, then that function is said to be odd function. So now let us now know about case 4 and 5 which of Euler's formula for even and odd functions. Euler's formula case 4. Now f of x is said to be even function in the interval minus L to L with the period what? L. With period L. Then we are going to get minus L to L fx dx will be equal to twice integration 0 to L fx dx if f of x is even. 0 if f of x is odd. Now let us find out how we are going to get this answer. Now we know that the function f of x is even. If the function f of x is even, then our Euler's formula a0 is given by 1 by L integration from minus L to L fx dx. Since fx is even, this whole function is even. The whole integral is even, and therefore a0 is even. And this can also be written as 1 by twice 2 by L integration from 0 to L fx dx. This is our a0. Now let us check for an. We know an is what? 1 by L integration from minus L to L fx cos n by x by L into dx. This is our even. We can write this as twice 2 by L integration from minus L to L fx cos n by x by L into dx. And what do we know here? fx is even, and even in this limit, this is from 0 to L. When we change 1 by my integration from minus L to L, it will be twice integration 0 to L. So when f of x is even, we know in this interval cos n by x by L is also even. Therefore, cos n by x by L is also even. And the product of f of x and cos n by x is also even. And therefore, an is even and it exists. a0 exists and an also exists. Now let us see what happens to bn. Bn formula we know it is 1 by L integration from minus L to L fx sin n by x by L into dx. We know that f of x is an even function, whereas sin n by x by L in the interval minus L to L is an odd function. The product of even and odd function is the product of this comes to be odd function. Since it is an odd function, the answer is 0, and therefore this bn coefficient will be 0, or the Euler's formula for this will be 0. This is case 4 that we have done for Euler's formula even function. Therefore f of x is now what? It's no odd functions are there, only even. Therefore f of x is an even function. Then the formula gets reduced. F of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n by x by L. And what is a0? a0 is 2 by L integration 0 to L fx dx, and an is 2 by L integration 0 to L fx cos n by x by L into dx. So we arrived at this formula. Now let us consider the second case, case 5. Now where f of x is an odd function here. See, in case 4 we studied f of x is an even function. Now we are seeing that f of x is an odd function. Now let us consider the first Fourier coefficient or the Euler equation 1 by L integration from minus L to L f of x dx. As you know, f of x is odd. So this integral is having an odd function. So a0 is odd. If a0 is odd, the answer is 0. Now let us go to the second Fourier coefficient or the Euler's formula 1 by L integration from minus L to L f of x into cos n by x by L into dx. We know here function f of x is odd and cos n by x is even. So odd and even function gives rise to odd function, and therefore here also the coefficient an becomes 0. And next, if we consider bn coefficient, that is 1 by L integration from minus L to L fx sin n by x by L into dx. Here the function f of x is odd, we already know that, and we know sin n by x is also odd. Odd and odd function give rise to even function, and therefore this function exists, and we will be able to write this as bn as 2 by L integration 0 to L fx sin n by x by L into dx. So this Fourier coefficient exists. So now let's write down what is f of x. Therefore f of x is an odd function. F of x is an odd function, and f of x is equal to summation n is equal to 1 to infinity bn sin n by x by L into dx. Because we know that a0 was 0 and ban was 0. So we know bn is what? 2 by L integration from 0 to L fx sin n by x L into dx. So we arrived at this formula for all the cases we have studied till now, till the 5th cases, and in the 4th session 4 we studied odd function and even function. That case 4 was even function and case 5 was the odd function. Now let us consider some note. Let me tell you how the Fourier coefficients behave in these notes and what are the results that we have already arrived, because it's important these results to solve the problems. Now integration minus pi to pi sin nx dx will be equal to integration minus pi to pi cos nx dx will be 0. This is a standard we have arrived. Now integration minus pi to pi sin mx into cos nx will be again 0. This is for both if m is not equal to n and for m is equal to n. For both the cases this condition satisfies. And from minus pi to pi sin mx into sin nx dx is equal to 0 if m is not equal to n, and pi if m is equal to n. Similarly, integration minus pi to pi cos mx into cos nx dx will be is equal to 0 if m is not equal to n, and pi if m is equal to n. These are the standard results. Now if we consider the rules of integration by Bernoulli's generalized formula of integration by parts, by parts we know integration of u dv will be equal to u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus etc. So we are going to use this. Thank you.